Hi, I'm Pat Shaughnessy. Let's take a look at the timeline for IEEE 1149.x. So starting in 1980, the 1149.1 specification was originally ratified. The reason that it was created was that consortium of companies got together and realized that ICs were getting more complex, pins were becoming surface mount, and boards were getting way more dense, so multiple layers, and it was becoming extremely difficult to get test points on a board or even on a device. So as a result of that, test coverage was going way down and yields were going way down. It was costing a lot of money to produce good ICs that actually worked. So companies got together and said, let's build a methodology that actually uses the device and does testing out from the pins while it's on the board. So that is how 1149.1 boundary scan was created. So the general idea is once you have a state machine in a device that allows you to control the pins and send data out and read values in, you basically have a test entity. And the standard is all about taking control of the device and isolating the internals of the device, be it a processor, an FPGA, or whatever it may be, and using those cells to control and interface with the outside world. So 1149.1 was the first specification for DC testing, and the idea is ones and zeros manifested in red on the pins of the device can be used to check for opens, shorts, and stuck-ats, either between pins, between devices. So the whole idea is you can build up very complex test vectors using pins and manifesting and reading values. So 1149.1 was digital. Next, there was a specification for 1149.7, which took the 4 or 5 wire JTAG interface and knocked it down to 2, which made it much easier to get the pins on a board so that you could interface to JTAG. In addition to that, there was a Star Topology in 1149.7. That's really important because on modern microcontrollers, for instance, ARM, for instance, based microcontrollers, lots of cores inside the device. Each of those cores, lots of cells. So with a star topology, we can actually communicate to each of them individually without going around the entire boundary scan register and taking a really long time to do a transaction. So star topology is very important for .7, but mostly used for debug, really not used much for boundary scan tests. Next was 1149.1, the 2013 revision, and things like PDL were put in. Also, ways to do initialization of a device, complex initialization to get power domains correct, to get registers set correctly, so that a device can boot up and be in boundary scan mode and be communicated with. The spec, just to give you a ballpark, went from around 200 plus pages to over 400 pages for this revision. Then finally, the 2015 revision of 1149.6. Again, 1149.6 is for LVDS signals, so basically AC coupled signals that have to get through a capacitor like Pixie or something like that. The idea is you have to have a cell on each side so that you transmit pulses, can go through capacitors, AC coupled through that, and you can have a device on the other end that's looking for those pulses, and as a result, you can test for continuity between the two devices. So that's 1149.6, and that's a quick overview of the timeline for the 1149.1 spec. In other videos, we will talk more about how the specification works and what you can do with it.